Good morning, y'all. This is Jeremiah Best with New York Agriculture in the Classroom. I'm a statewide educator. Today, we want to talk with you about the phenomena of density in agriculture, and specifically density in the maple industry. We see density used in other places, things like growing hay, as well as other products, but with it being the maple season, we want to discuss density in agriculture. So the phenomena would be, why is density important to the maple industry? And the answer is quite simple. Density plays a major impact on what the end product is, the maple syrup, but as well as how much sugar is in the sap that we're collecting. There's a lot of research being done right now where researchers are looking to develop trees that have more sugar. On average, most maple trees have about 2% sugar in their sap. Red maples have a little less than that. And then as we get into other types of trees like birch and beech and walnut that we can tap, we're talking about a lot less sugar, less than 1%. So density, working off the definition that density is the amount of stuff in an item, when we're talking about the mass, the atoms, the atomic weight, and how tightly those things are compacted inside an item. When we look at things like styrofoam in a rock, if we put styrofoam in a bucket of water, we'd expect it to float. We put a rock in that same bucket, we'd expect that rock to sink because that rock is denser. So we're going to take a look at how we can measure that. So in the maple industry, as well as other types of agriculture, we use a thing called a hydrometer. We also use a refractometer, which is a little eyeglass that you can put a bead of syrup on, and the way that the light reflects or refracts off that syrup will give you a reading, which can show you the density of sap and syrup. But we're going to work on we're going to use a hydrometer. So the first hydrometer I have is a syrup hydrometer, and this has been weighted here at the bottom to be able to measure the amount of sugar. And the unit that we use in maple production is called the brick scale, and that just measures how much sugar or what percents of sugar is in our final product. So the definition for maple syrup, when we're talking about commercially, and to be sold commercially, we need to be 66% sugar. You can see here I have two red marks. The first red mark is my hot test. When the syrup is hot at 211, those atoms are going to be more excited, so I'm not going to have the buoyancy or the density. As it cools to 60, we'll see that the measurement is right down here at 66 bricks, almost 67, so 66.8. So we are going to make our own hydrometer in our hydrometer kit. We also have another hydrometer, which is a sap hydrometer, and you can see it's much smaller. And what we do is there's little sap cups, which is a long cylinder, much like the graduated beaker that we're going to use today. And you collect some sap and you drop this inside. And we will use this one and discuss hydrometers a little further, but you can see here it starts at 0 bricks and comes down to 8. There are things called super trees, and there are some trees that will produce 4, 5, even 6% sugar content sap. So for maples, it's important. The sap flow is extremely important for all trees, as when we're talking about deciduous trees, is because what they have done is from the year before, through the process of photosynthesis, they have taken those sugars and they have stored them into their roots. As the leaves fall off, photosynthesis stops, and the trees go into a period of dormancy. For us as maple producers, we can tap into that. So when we put our taps in, we are drawing some of that energy from the tree that it's shooting from its roots back up to the canopy to promote leaf growth. and start photosynthesis over. So it's a very cyclical process. So when we tap in, we're tapping into that process. We're only taking a small percent of the energy that tree needs. That tree heals over, and there are trees that have been tapped for multiple generations, 100+ years. So when you do it correctly and you do it carefully, you're not really going to damage that tree. So as a maple producer, I like to know my numbers, and I like to know what percentages are out there. What's my density of the sap? So right now our sap just released, and we're starting the maple season. So what we'll do is we'll go out with our sap hydrometer and we'll test our sap. As we boil down and things get denser, we'll use our maple hydrometer. Per law, for us to sell it, it needs to be at that 66.8% sugar. So we need to be able to measure that density. So in this lesson, we're going to take a quick look at how to create your own hydrometer with your classroom. So first off, I want to share some of the resources that we have set in your kit, or if you want to have your own kit, some quick and simple resources that you can purchase. So the first thing is you're going to need a graduated cylinder with 100 milliliters or 100 milliliters marked off. We have some small nails. You're going to need a straw. And in your kit, you should have straws. I prefer a fine tip permanent marker. If you don't have a permanent marker, when you're testing your hydrometer in different kits, that's going to wipe off. You're going to need a metric ruler. We did include stir sticks to stir your solutions. You're going to need some kind of plasticine or clay that will be able to repel water and keep your hydrometer sealed. If you look at the bottom, if you look at our hydrometer, it is a sealed unit. Now we won't seal the top like this hydrometer, but we will seal the bottom with the clay. And then because we wanted you to be able to test different solutions, we did give you some sucrose or some sugar to be able to create a solution, a sucrose sugar solution. So the first thing that you need to do is you need to take your straw, and we need to create a scale that we are able to use to compare the different types of solutions that we're going to measure. And the way we do this is we come down to the metrics, and we're going to mark off every 2 millimeters. We're just going to put a little line, 2, 4, 6, 8. Now, when we get to the centimeter, we're going to do a larger line. So every 10th millimeter, we're going to do a larger line. So again, 2, 4, 6, 8. And on the 2 centimeters or 20 millimeters, we'll mark a larger line. So here's the beginning of my hydrometer. You can see every 2 millimeters, I have a mark. And then at the 10 millimeter or 1 centimeter, I have a larger mark. What I like to do is I like to go all the way to the 10 centimeters or 100 millimeters to give me something for my eye to compare and to be able to look at. So my next step is, once I have my scale marked off on my straw or my hydrometer, I take a little piece of plasticine or clay. I've even used butter if you're in a pinch. We can talk about fatty lipids. That's a whole nother lesson, but it will repel water, at least long enough for our purposes. And we're just gonna press the clay into the bottom of the straw and seal the bottom of that straw. And you can see I have my sealed clay. The top part of my straw is open, and there's my clay. Now our next step is to add the small nails to the hydrometer. I have found, if you take a look at the commercial hydrometer, they have quite a bit of weight here at the bottom. So if you were to add one nail, what would happen is when I put this hydrometer into the water, it's going to press down. I might get it pressed down to 20 millimeters or 2 centimeters, but it's going to be pretty unstable. So it's going to be hard to measure. So what I have found is that I want to continue to add the nails until I get up here to the 90th millimeter or 9th centimeter, the 9th long line. And what that does is it just gives my hydrometer a little more stability in any of the solutions that I'm working on. I found that if I add 14 of the small nails that we provided in our kit, they're little finishing nails, that will get you close to that line. So once you have your hydrometer built, you can see my nails. You can see that I have it sealed. The top of my hydrometer is not sealed. I'm not concerned about that. This is not going to go below the level of the solution. I want to get 100 milliliters of water. Now, when we talk about density, we can get quite precise with things. So if I really wanted to be precise, I could use deionized water. We're on a well, so our well water is going to be a little more dense with some of the minerals in the well than you might have with ionized water or city water. So our next step is we want to take our beaker. And you can see I have 100 milliliters of water. And we want to have our science journals or our recording sheet with us, and we want to test our hydrometer. So what we do is we just slowly lower it, and we do this exact same thing in the maple industry. We would lower it in, and you can see that I'm right around that 90th millimeter. I'm a little over, but I'll be right around that same. Now, I'm going to use the same hydrometer in other solutions. So I marked my first I was at 92 millimeters. So when I test in the next solution, it's going to be the same hydrometer. That initial measurement is going to give me that initial read. So it's like I'm setting, tearing out the scale. I'm setting the scale. So this hydrometer has now been set, so it's able to be compared from water. We know that 1 gram of water is equal to 1 milliliter of water. As I add different densities, that's going to change. That solution that I measure is going to be either more dense or less dense. So once we have our students measure the water and set their hydrometer, and I'm going to go ahead and measure it with my SAP hydrometer. Now this hydrometer, we should have a 0 scale. And you can see as it is right around 0. So this hydrometer has been measured and has been set up so that it will measure 0. So if I was to start to add sugar to the solution, what we're going to expect this hydrometer and what happens in the sugar bush is we'll see this hydrometer start to rise. And I was measuring in the sugar bush just this weekend, and I had some trees that were at 2.5%. Might get a little bit of gain as the trees start to wake up, some more sugars in the sap. but we were right around 2, and it was floating, and you could see that it was more dense. So our next step is we're going to take another graduated cylinder, and we're going to make a 20% sucrose solution. And we're going to measure that with our hydrometer. And we want to answer, is it more dense? Our question is it more dense, that sugar solution more dense than the water solution? So we'll use that hydrometer to figure that out. In a quick, easy way to make a 20% sucrose solution is if we measure out 80 milliliters, and then we are able to take our sugar and raise this water level up to 100 milliliters by adding sucrose or sugar to that beaker. So again, what we do is we start at 80, and we're going to add 20 milliliters of sugar, or we're going to make that go up to 100 milliliters. That's about 20%. It's not precise because sugar, a gram of sugar is not equal to a milliliter of water. So it's but it's around 20%. And we can do that same process with things like salt or anything else we want to add to water to check the density. So again, all we do is we start with 80 milliliters. I like warm water because it helps to dilute that sugar or salt or other items. We can use sweeteners and compare those and raise the beaker up to 100 milliliters. So our first step was to set our hydrometer with 100 milliliters of water. And our next is to create a solution using sugar or salt or sweeteners. You can also use corn syrup, and you can compare the density of these different sweeteners. If you have sap, you're more than welcome to use sap. Because a lot of teachers don't have sap readily available, we did include the sugar. So here's a beaker where we started with our 80 milliliters of water, and we raised that up to 100 milliliters by adding 20 milliliters of sucrose. When we tested our water, we're right here at the 92nd millimeter. And we'll go ahead and we'll add our hydrometer. And as you can see, we are now at about 80 centimeters or 8 millimeters. So what we can conclude is that this solution is more dense. The sucrose solution is more dense than our water solution by using our hydrometer. Now, if we were making maple syrup, our hydrometer for maple syrup is set so that it's measuring syrup. So it's set to identify 66% sugar. So we're looking at 20% sugar with that sucrose. We can try that by adding sugar and mixing it. It'll be tough without adding heat to it. But what happens is we have a ratio in maple syrup, which is 40-1. So for 1 gallon of maple syrup, we need 40 gallons of sap. And the way that we make it dense, we can do that in 2 ways. One, mechanically, by forcing sap through a reverse osmosis machine, because those sugar molecules are larger than the water molecules. The water goes through, what's left is a permeate. So there's more sugar in the water, and that lowers our boiling point. But to make the flavors, we really have to, at some point, add heat to add that crystallization and caramelization. So what we do is we put our sap on a evaporator, and that's exactly what it does, is it evaporates the water. It's just basically a big pot. So as we evaporate that water, we get to the sweet spot, which is 66, 67, 68. And we raise that density of sugar so that our syrup is 66, 67% sugar with 40% or 28 or 24% water. Now, if we take it past that, which we can do, we're starting to look at things like making candy and maple creams and things like that. We can make hard candy from maple by continuing to make that solution more and more dense. If we go below that 66%, what it does is it starts to allow bacteria growth. And so then our syrup starts to spoil. So a quick, easy way to be able to identify the importance of density in the sugaring industry. We can discuss that maple trees are, when tapped, provide us with sap that is 2% sugar, so very low sugar density. As we evaporate, we are raising that sugar percentage and making that solution sweeter and sweeter until we get to a place that we're at 66% sugar. And then we have our syrup, and we can look at things like viscosity also. So we're making that solution more viscous through increasing the density. And that we can continue that process to where we boil out the waters. Then we're talking about that solution becoming denser and denser and forming sugar crystals. So quickly, we'll run through it one more time. Is the first step we want to do is we want to take our straw. The next step is we want to measure every 2 millimeters with our metric ruler. When we get to the 5th measurement, we want to make a longer measurement so that we can compare. We can go by groups of 10. So every 10th millimeter or on the centimeter, we mark that off with a thicker line. I like to go up to 100 millimeters or 10 centimeters to allow me to gauge things and give my eye something to compare. Once I do that, I want to add the nails until I get to about the 90th millimeter. And once I have added enough nails for it to be there, I then put this into 100 milliliters of water, which will give me my base. It will give me, it will set my hydrometer to then be used in other solutions. Once I've done that, I can either put 100 milliliters of a Coke or a pre-made solution, or I can make my own solution by putting 80 milliliters of water into a graduated beaker. And then I can raise that up by adding different compounds. So it can be salt, it can be sugar. I can measure the density of these other solutions. So hopefully that helps to answer any questions and helps you to work with your students on how to identify the importance of density in the mapling industry. It's also used across, just learned this summer when we were on a tour on a farm, that hay farmers that grow hay or feed cattle measure the density or the sugar in their grasses with this same product. And so they create a solution with their grasses, and they're able to measure the sugar content in their grass, and they can estimate how much feed that they need. So density is extremely important in agriculture. I hope you have enjoyed this lesson, and if you have any questions, please reach out to me. My email is jjb386@cornell.edu, and I'd be more than happy to help y'all. So have a great day and enjoy learning, and thank you for all you do. Bye now.